Hello and welcome back to Critical Borders for our final half day. We've had a phenomenal couple of days of multidisciplinary scholarship that's given us critical insights into how AI produces or transgresses imagined theoretical and ideological borders. We've explored so far how AI operates at national and bodily borders, and indeed our two panels on AI nationalism and the borders of the nation-state have demonstrated the current widespread concern over AI's exacerbation of violent bordering processes. We've also explored the racializing consequences of AI's erasure of ambiguity, what science fiction has to tell us about AI and care ethics, and how art can mobilize and manipulate AI in new and potentially subversive ways. We've got two panels to look forward to today, the first on patents and the geopolitics of AI, and the second on AI, art, fashion, and style. Before we begin our first panel, I wanted to focus the spotlight on the people that our virtual audience might not have seen or might have only partially seen, the amazing people working behind the camera to make this all possible, who are all incredibly interesting and accomplished people. I'd like you to know a little bit about them because they're the only people that we haven't heard from this week. So firstly, Rachel Burgess, Tony Leach, Laura Elmer, who have worked tirelessly to make sure everything runs smoothly. Rachel leads the professional services support team at the Centre for the Future of Intelligence and the Centre for the Study of Existential Risk, and we're incredibly lucky to have her. Tony is a research assistant for the Global AI Narratives Project and a PhD candidate at the Centre for Computing and Social Responsibility, focusing on fictional narratives and the discourse on discrimination in global AI policies. Laura is an administrative assistant at the Centre for the Study of Existential Risk, as well as a freelance filmmaker and video producer. And thanks also to Nick Devlin, who's been helping us run the floor, and who's just completed his PhD in the political thought of ex-communists. Many thanks to Isabel Higgins, who stepped in last minute to wield the mic in our Q&As, and who's doing a PhD in the digital mediation of transnational and transracial adoption in the USA. And she's also the convener of the Phenomenal Race Research Cluster that I had the pleasure of attending last year. And last but not least, many thanks to Mark Creswell and Jeremy Dawson and the rest of their team here at Jesus. Mark and Jeremy are the AV specialists that have brought this so beautifully and so seamlessly to your screens. I'm sure there are many people I haven't mentioned today, so can we give the mentioned and the unmentioned, both here and at home, a big round of applause. And with that, I'll hand over to Kanta to introduce Ned and our next panel, Patents and Geopolitics of AI.
Thank you very much, Eleanor, and let me just add my wholehearted thanks to all the people that she just highlighted and everyone else who has made this possible. Welcome to our final day, which is going to open with an all-virtual panel from Australia and Canada, joining us at 7:30 p.m. and 4 a.m. respectively. So many thanks for being so flexible with your schedule and sleeping patterns. This panel is titled Patents and the Geopolitics of AI, where in this panel has been looking at the ways patents for novel automated processes and systems of AI and machine learning register a universalizing tendency in their design and speculation of technological innovation. Such a tendency may be indicative of globally shared data science research, but it's also suggestive of the physical spatial architectures of commercial logistical systems, such as Amazon and Alibaba distribution and fulfillment centers, for which the AI is developed. Bounded by representational conventions, linguistic tropes, and legal regimes, patents assume a territorial function, alerting potential competitors that certain ideas are already occupied now and in the future. And the multifarious borders at play here, not so much national, but rather technical, geopolitical, and imaginary. Although the fact that patents are registered with national as well as international agencies reintroduces bordering dynamics that cross the techniques and technologies that they enclose. So I'm now going to hand over to Ned, who is chairing the panel virtually for his project. Ned, over to you.
Thanks very much, Kanta, and thank you, Tony, also for all your help in the back end of things here. Well, good morning or good evening, wherever you happen to be in the world. We're really glad to have this occasion to bring our initial research together around a project investigating the geopolitics of automation. It's a project funded by the Australian Research Council and has a particular focus on AI and machine learning in warehousing industries in Germany, Malaysia, and Australia. We're interested in warehouses as theatres of struggle that tell us something about how AI and machine learning index geopolitical contests beyond the sort of accounts we might read in area studies or international relations, among other fields. Our speakers today are part of a wider team of researchers based in Australia, Germany, Italy, Hong Kong, and Canada. And because we've been unable to travel the past 18 months or so, our usual mode of collective research around the sites of investigation has had to come up with other approaches and methods. And these include examining patent technologies as points of entry into the politics of AI. Today's presentations begin with a paper by me and Arit, then Tsvetelina, Anna, and Liam, and we close with Brett and Zoe. Because it's this kind of rather brutal hour in Canada at the moment for Arit, 4 a.m., we decided to spare her of having to try and articulate herself at that kind of horrendous time. So I'll do my best on that side, and Brett will present the paper with him and Zoe, and then we have a gang of three taking up the kind of the middle period here. We'll go for 15 minutes with each paper about, and then take some questions at the end. I'll just set up this slide now. Okay, I believe you can see that. I can't see you, so are you seeing the slideshow and not these bios? Okay. To begin then, patents are legal technologies that enclose futures not yet born. As anticipatory devices, patents assert control over the territory of invention. More often, the economies staked out are still born, never to emerge beyond the theatre of arbitration in the event of dispute. Parading an aesthetics of minimalism, patents distill an idea of action as bare essence. The sequential logic of instruction, of rules on how things work, registers affinity with the family of algorithms. Closing down options, patents seek to define the relation between cognition and invention, production and command, capital and labor, according to supranational juridical regimes. All too often, such gestural authority fails in the face of defiant states and cultures of piracy. Automation patents foretell a world of machine operations that eclipse human life, or at least dispense of the subject of flesh and pain that endures servitude to capital. Only this is no post-work future, but rather another form of indentured labor in which consumption is tied to data architectures that authorize transactional compulsions. The patent provides the diagram.
So, Ned, sorry to interrupt, but your PowerPoint isn't full screening. Could you press the full screen button again, please?
You've got a black image there now, is that right?
We've got the full PowerPoint overview.
Just the title one. Does he want to be moving forward? I think he needs to be moving forward through the slides, or he wants to be on the first slide.
Oh, I think
it's full slide here, and then I've got black intermission slides.
I think if it's full screen on your then your probably sharing the wrong screen.
Oh, okay. Let me try again. You have the full
That's
title
the one,
slide
yes.
there?
Hooray, we have the full
And
title slide, yes.
And now you have a black screen.
Indeed.
And then you'll have an image screen in a second.
Okay, perfect. Thank you very much.
No, thank you for letting me know. That's great. The patent then provides the diagram of capture. As a proprietary form, patents police invention with the force of the law. In hitching the formalization of an idea to legal doctrines of ownership and control, patent law exposes its vulnerability to agents who care less for such quarantining of expression. In their paper, Zoe and Brett examine the nexus between patent law and territorial jurisdiction and the challenges AI present to ideas of law as sovereign. Needless to say, patents provide a skeletal imaginary of how automation technologies proliferate within concentrated world historical sites, invested in organizing space and time in ways congruent with the accumulation of capital and articulation of geopolitical power. Environments comprise radical new forms of governmentality, generating new epistemological grammars coextensive with their territories of operation. The logistical facility of the warehouse, for example, is at once an environment that experiments with automation technologies designed to manage storage, distribution, and labor practices. And it's also a test bed that envisions how environments might work in more expansive ways as a management system that organizes, coordinates, and assigns inputs and outputs in the governance of signals to produce parametric horizons that optimize the engineering of life. Patents offer a point of entry, as I mentioned at the beginning, into the design of automated warehousing environments. For example, much industry reporting and academic study has been done on Kiva Technologies' patent for robotic transport devices able to move heavy stacks around the warehouse settings. Acquired by Amazon in 2012, the initial idea of a mobile inventory stack was further developed to include a metal cage for workers with additional robotic extensions able to expand the repertoire of human-machine tasks. Splicing fulfillment centers with logistical supply chains. Another of Amazon's patents filed in 2017 for intermodal vehicles embraces elements from the genre of science fiction film in its repertoire of patents on anticipatory shipping. Dependent on existing rail transportation infrastructure, a core premise behind this patent rests on the reproduction and reinforcement of established patterns and demographics of consumption. This is not a case of a rail to nowhere, but precisely the opposite, where customer purchase histories determine the deployment of intermodal vehicles loaded with inventory targeted to fulfill already acquired habits of consumption and cultures of taste. At this basic level, the relation between production and consumption is already automated, independent of technical operations pertaining to machine learning or artificial intelligence. Once these additional technologies of automation are enlisted into the diagram of logistics, new kinds of environments and epistemological universes are produced. Patents of this kind also register the articulation between environment, epistemology, and geopolitics specific to technical logics of automated worlds. So how is geopolitics automated? By technical systems, computational processes, and infrastructural components, coupled with policy agendas and economic targets designed to obtain hegemony through the production of territory. The spatialities of power generated by machinic operations may reinforce and extend more conventional techniques of geopolitics, staged in the theater of interstate contest between civilizational cultures, articulated through Cold War disciplinary legacies of international relations and area studies. More likely, however, the automation of geopolitics results in novel territorial configurations, not easily subsumed by the geopolitics of interstate rivalry. Even less so by the neo-Darwinian and racist logics of species being promulgated by area studies. Indeed, the automation of geopolitics is accompanied and conditioned by the geopolitics of automation. Whereas the former consists of the machinic production of territory, the latter involves state actors recalibrated by the struggle to determine the standards, protocols, financial and operational logic of machines. When geopolitics are automated, machines take command. Such command cannot be thought of in terms of Cold War control or domination over stable territories. Amazon patents reveal that the new conception of the procurement zone will be mobile and aerial, capable of producing domains and territories through service and accessibility to consumption rather than around other categories of citizenship or real estate. Nowhere might this be made more evident than in the exemplar of new forms of roving territory envisioned by Amazon. In this patent, procurement centres are airborne and capable of entering new locations, often more targeted services through the use of drones and a capacity to transport to spaces of fulfillment. This strategy of mobile zones is related to new forms of warfare with other corporations. Aerial control has been the linchpin of war and geopolitics in the 20th century, the first frontier where pilots were treated as machines. The original vision, first recognized by Buckminster Fuller, of a world whose cartography was organized through logistics of aerial warfare. The previous Amazon images even looked like aerial warfare. This map is the world as seen from airplanes rather than other vantage points. It's a world that can be reorganized and reconstituted at will. The logistical and mechanical vision, first recognized in 1944, might finally have been realized, but no longer, however, in the service of the racial and geographic orders of the nation state. The current battle on a planetary scale between Amazon and Alibaba serves as a case in point of this transformation. The dance of artificial intelligence and machine learning, specific to these two state-affiliated global companies, bears witness to the ways in which the geopolitics of automation exert pressure on labor in the process of accumulating revenue from the traffic and commerce. Amazon is well known for its pursuit of a business strategy of total organizational and logistical control with vertical integration in their platform, all the way from sales, storage, services, subscriptions, and distribution up to the last mile. By contrast, the Chinese tech giant Alibaba prefers to enlist third parties to horizontally expand its range of data-driven services that include real-time microcredit and financial loans, inventory management, consumer profile, search rankings, as well as logistics and warehousing. While Amazon and Alibaba hold complex and quite different relations to organs of the state, for instance, the former piggybacks on US postal service infrastructure, while the latter is protected by and at the mercy of crack decisions in Beijing, both companies are in the game of market domination. Where they differ is in how territories and thus corridors of data, supply chain traffic, and labor power are produced through technical operations and infrastructural systems. The production of time and space, subjectivity and sales, specific to automated processes of decision-making, registers new forms of geopolitical power that at once unsettles and intersects with the sovereign authority of the state. The new capillaries of control generated by this constellation of forces are not immune to intervention and destabilization. Such is the revenge of the world. In this little short final section here now, I'll look into the idea of designing epistemes. So does the agglomeration of data, its processing and analysis, result in computationally defined parameters that inframe how world situations are understood more generally? Can we discern a design logic that informs and indeed produces computational rationalities spawned by automation technologies? Indeed, might machine learning and AI processes in the logistical facility of the warehouse register the emergence of epistemic planes of operation that calibrate society as if it were inventory to assign, distribute, and exchange? Such would be the horror of a world as warehouse. But can we think in slightly more compelling horizons where something might actually be at stake? Can intelligence work in and alongside and against the overdetermining tendencies of AI unleashed onto the world. If the patent anticipates futurity as property filed in the present, how might patent analysis generate critical cartographies of geopolitics tied to knowledge regimes specific to machinic operations? Or perhaps even suggest that we must escape the tyranny of geopolitics, a possibility that might open to new forms of political action and affiliation. An analysis of how epistemic conditions are tied to industrial technical objects is something we'll hear more about shortly in the paper by Anna, Liam, and Tsvetelina. Suffice to say that semantic classification systems of patents and the sort of parameters that attend patent archives invite and indeed support a critical practice of distant reading. Closely associated with the work of literary historian Franco Moretti and adopted as a method in digital humanities, distant reading lends itself to analysis predicated on statistical tendencies from a corpus of data. In the case of online patent archives, we start to see the composition of the research landscape in computational science in terms of institutional affiliations, knowledge concentrations, and geographic distribution. Such patterns tell us not so much about the geopolitics of automation, but rather the geoeconomics and political economy of research in the field. The diagram of knowledge coincident with such relations has implications for research and development in the automation technology industries. An episteme of automation is produced. The remaining two papers in this session do some of the more substantive work then in technically and empirically accounting for AI patents designed for automating warehouses. And at this point, I'll now hand over to Anna to begin the second paper. Thanks a lot, Anna.
Thanks so much, Ned, and Ovid as well. Thank you very much. I'll just share my screen. So hopefully everybody can see that. Great. Okay. Well, we've been in the air, and just before we get into the patent database, I'll just acknowledge the traditional owners of the unceded lands of which I'm coming from, the Gadigal people of the Eora Nation, and pay my respect to all First Nations people, past, present and future, and acknowledge that sovereignty has never been ceded. Okay, let me plunge in, and then we'll distribute the paper between Tsvetelina and Liam. Okay. Industrial objects, both inventoried for the purposes of computer vision and operatively deployed by warehouses such as Amazon and Alibaba fulfillment and distribution centres, are increasingly constituted and logistically dispatched via automated processes and functions, large-scale patent datasets, bin packing algorithms, and image recognition AIs. In this paper, we begin by asking what data is required and accrues around contemporary industrial objects via automated processes. How do these practices relate to past and present taxonomies of what constitutes an industrial object? We focus on the recent development of a patent image database by a team of Chinese researchers and industry partners called PatentNet. This project points to the intersections and contradictions between regimes of classification in the context of production, circulation, and machinic control. These different regimes suggest the convergence of geotechnical, geopolitical, and geoeconomic spaces that are articulated through the industrial object and its transversal relations to varying systems of organisation. Increasingly, the contemporary data surrounding industrial objects departs from the landscape of industry, standards, and semantic classification toward concepts and practices of neural nets, automated recognition, and machinic vision. We draw on different approaches to the industrial objects data to outline this shift.
Sorry. Okay, so within the warehouse, industrial objects partake in a particular taxonomy that is concerned with the way they move, the space they take, and the profit they generate. Commodities categorized into stock keeping units, or SKUs, are defined by their unique qualities as marketable goods. Each product has a unique SKU in the warehouse, and each of the SKUs is assigned a category within a system of inventory management. This type of taxonomies, called ABC and XYZ, assist in creating heat maps of the warehouse inventory, showing which products tend to circulate quickly and leave the warehouse soon, and which have a slow rate of circulation, which are the ones consuming the most value and which the least. The heat maps inscribe the relationship between value and speed of circulation onto the architecture of warehouses, the arrangement of racks, and the paths for reaching and picking packages. While objects themselves are contained and remain invisible within packages, they become part of the visual and spatial grammar of the warehouse, which articulates the tension between circulation and containment and the potentiality of exchange value. This visual epistemology of the warehouse, as Dara Orenstein calls it, builds on the practices of recording and ordering that underpin inventory lists, stock databases, and warehouse management systems. While this visual spatial grammar of the warehouse is instrumental in certain types of automation, for example, in autonomous guided vehicles, there are points of friction where the visual epistemology of warehoused commodities breaks down and becomes unintelligible. Anna, can you please move? Yeah, thanks. One such example is SAP's handling of returns of mantle figurines sold by the company Ladro. This company sells expensive porcelain figurines online that cost in the range of thousands or to tens of thousands of dollars. And at some point, they realized that there was a problem in handling the returns. Reverse logistics, or returns, are the most difficult and time-consuming to automate and are labor-consuming part of the supply chain. Unlike outbound logistics, where as one of the managers at SAP responsible for Internet of Things and digital supply chain solutions explains, workers can be almost like robots and just take the parcel and send it forward. Returns require skilled and experienced labor. Workers need to be able to quickly evaluate the condition of the returned item and pack it back in its original packaging so it can be sold again. Can you move to the next one, please? But in the case of Ladro and their kitschy and expensive figurines, SAP was faced with a different problem, human error. Often customers would buy a few of them and then send back some, mislabeling which ones they kept and which ones they sent back. Sometimes they would send back fakes, and sometimes they would keep the more expensive ones, send back the cheaper, but demand refund for the expensive ones. These figurines look very similar to each other, and once they're separated from their identifying SKU and barcode, workers struggle to tell them apart. So SAP helped develop an AI solution for returns using the image recognition capabilities of Google Vision API. This cloud-based platform tool compares features of images of the returned products to features of images of the originals found on the internet in order to determine whether the returned item is genuine or not, and whether it is the one for which the customer asks a refund. Here we have the third largest global and non-US software company, SAP, seeking AI assistance from Google. The shift towards machine learning in industrial automation also sees shifts in geotechnical alliances. That was me.
In June of this year, a university and state consortium of machine learning researchers from the Guangdong Provincial Key Laboratory of Intellectual Property and Big Data, conducting research for China's Intellectual Property and Patent Office, announced the release of the 6 million image dataset, PatentNet. With promises to expand to 60 million images over 5 years, PatentNet contains image and text data sourced from patents of industrial objects, classified according to the globally standardised Locarno classification system for industrial designs. PatentNet can be seen to embody the data necessary for generation and oversight of future industrial objects in ways specific to machine learning-driven AI. It's not difficult to speculate that such a large-scale database will be used to develop AI models for seeing and analysing global products, and potentially could become a flagship of China's ongoing impetus toward smart computing. As a database, PatentNet retains attributes of an older epistemic system that has indexed patents through a classification mode endorsed and regulated by a now fading global geopolitical order. Its millions of images are organised into the 32 classes and 219 subclasses of the Locarno Classification Agreement, LCA, assigning patents a class, and I quote from the agreement, according to their purpose and subsidiarily according to the object that they represent. Function first, image second. The LCA is entirely embedded in the 19th and 20th century European geo-economic project. Established in 1968 by countries signatory to the 1883 Paris Convention for the Protection of Industrial Property, it followed hot on the heels of the setting up of the World Intellectual Property Office in 1967. The WIPO was established to structurally reform patent and trademark governance so that its member states could decide and control the development of international relations in the field of intellectual property. This reform was ensconced within a larger project of bringing the WIPO under the auspices of the UN as a specialised agency. China was admitted as a member to the Locarno Agreement in 1996, indicative perhaps of the EU's then increased interest in trade relations, evidenced in its new Asia strategy. The US, interestingly, has never been a member country. PatentNet, however, produces data about industrial objects by stripping patents of their authority as unique documents protecting invention. Instead, they become raw source material for its database, reorganising their elements according to machine modes of vision and recognition. It handles patents as ultimately dissolvable into features of an ever-expanding inventory of industrial objects, and hence shares similarities with other automated inventories arranged for and controlled by computer vision systems for the distribution and storage of goods in warehouses, as Tsvetelina was outlining. If patents require standardised classification to index and search them, such as the Locarno classification, then bodies and institutions governing and administering these systems must also exist. However, if patents are increasingly treated as machine-readable data, then they are likewise knowable by assemblages whose geo-economies may be both localised within provincial smart precincts, such as the Guangdong Hub, and distributed by platform economies of academic and corporate machine learning. Here, the patent, like the image, becomes an object multiplied, fragmented, and distributed over many views. It's worth thinking about PatentNet then as a kind of intermediary technical or computational object. It reaches back into a genealogy of classification indebted to a general European project, but it also stretches outwards to a geo-economy in which the look of things increasingly features in the data.
Thanks, Anna. And partly motivated by a desire to experiment ourselves with technical methods, we also consider how PatentNet as a paper reaches back into another kind of genealogy of scientific inquiry itself, which manifests through practices of scholarly referencing and which can be traced in an automated way due to the rising frequency with which scientific papers themselves are published on repositories like archive.org, where we initially located PatentNet. And to think through such possibilities, when we wrote code, as this diagram illustrates, to parse a scientific paper, to extract its text and references, and when available, to download references from archives. And taking PatentNet as a seed or kernel paper, we apply this process recursively to produce a text corpus and database of linked papers. And we analyse in turn these outputs in terms of keywords and topics, timelines and geographies of publication, and networks of association. And how such analysis might connect up with our other methods, Tsvetelina and Anna have been talking through, of approaching patents, that is through key-informed interviews and analysis of standards and classification systems, remains a work in progress. But we present these sort of interim findings as a kind of impressionistic gallery of data representation that alludes to a wider epistemic shift underway, as Ned had indicated, with respect to classification methods. So first, next slide, please, Anna. First, we show here just the number of references extracted in papers downloaded, and then to continue. The accompanying network diagrams, both this slide and the next one, depict the rising interdependence between the papers as we extend analysis from 1 to 3 degrees of separation from the original PatentNet paper, with several interconnected papers acting in this diagram as kind of foundations from which more applied and industry-oriented articles like PatentNet develop. And moving on, the frequencies of terms that are extracted from this corpus of papers extracted show a conceptual transition at work. If we just go back one slide, Anna, please. So PatentNet itself refers to terms from industrial and information retrieval disciplines, as well as machine learning. These quickly drop away as we proceed, as the corpus is extended, until what remains is a kind of pure language of machine learning, where classificatory and logistical terms like taxonomy, SKU, design, category, hierarchy, and even class itself are notably absent. It is the vocabulary of the image, network, model, layer, and feature that eventually dominate. And topic modelling, moving on one slide, a means of extracting clusters of associated terms from the entire corpus reinforces this machine learning-centred view of classification, a transition then from, as Anna was outlining in different contexts, from function to feature. Moving on, charting publication years shows 3 periods. So when we kind of map the kind of years of publications for all of the references that we extracted, 3 periods: early precursor works up to around 1997. From then, the next decade, from 1998 to 2008, a period of experimental developments, and really a sort of publications since 2009, where each year produces 50 or more references, and really showing the sort of very recent sort of frame of referencing that scientific inquiry in general, but machine learning particularly utilises. And so finally, country name frequency across the corpus shows an expected geography centred on Asia, Europe, North America, and in our sort of tests, global South countries mostly produce 0 results. So such countries as our references across this kind of corpus of documents remains kind of centred on the global North. And sort of towards our conclusions, our analysis of frequencies and topics here then suggests a transition from the expected mix of material and immaterial industrial objects in the PatentNet paper itself, where references to fashion, furniture, and cars sit alongside discussions of data clustering techniques, to a concentration of machine learning and image classification terms in the wider corpus. And this can be seen as marking a transition from an anthropocentric, functional, dynamic and temporospatial view of the conventional classification information system to one that is driven by machine recognition of features, static and arguably spatial only, and we're sort of debating this internally, in the digital representation of industrial objects. And this transition does not prevent the results of such recognition being brought back into other logistical, legal, geopolitical, or geoeconomic registers of meaning. Indeed, we note that the PatenNet paper itself champions a multi-view approach, which we can readily think as extended beyond the literal image itself to all kinds of fragmentary, feature-oriented, data-centered perspectives. Primarily disinterested in those features of industrial objects that intersect with worlds of extraction, labour, proprietorship and circulation that Reed and Ned gestured towards, scientific papers are themselves amenable as technical artefacts to decomposition in ways that yield yet other views onto those objects and their organisation through systems such as PatenNet into shifting geopolitical orders. And on that note, I'll now hand over to Brett and Zoe.
So while Zoe's sharing the screen, I just want to mention that we're speaking from Bijigor lands. Okay, I'll make a start because we need to do so. What can a patent do? With respect to artificial intelligence, this is a question that largely remains unanswered, although likely to work itself out in coming years. The colonization of artificial intelligence research and commercial application by machine learning certainly has ramifications in the legal realm of intellectual property, especially patenting. The recent Tala decision in Australia, recognizing a machine learning system as an inventor, is a register of this impact. However, the implications of this decision, which await the result of an appeal, are separate from the problem that concerns this paper. That is how the intersection of artificial intelligence technologies and patenting techniques generates cleavages between territory and jurisdiction with geopolitical import. We look at the proliferation of patent pools, patent thickets, and standard essential patents that provide the legal environment into which artificial intelligence moves in order to find a means of examining emerging struggles along the borders of technology, state, and capital. Now, the horizons of of AI research reveal thick patterns of international scientific collaboration. But the intellectual property regimes into which the resulting routines and inventions enter are strongly territorialized. From the 1990s, the internet distribution of protected works, signs, and inventions sparked questioning of the principles of lex protectionis and territoriality that underlie intellectual property law. One area of intellectual property law in which the conflict between these principles and a more harmonized or universal approach is still pronounced is the question of jurisdiction for decisions concerning worldwide, fair, reasonable, and non-discriminatory, that acronym is FRAND, FRAND royalty rates on standard essential patents. That is, patents that are essential to the manufacture and sale of standardized products. Now, most FRAND decisions thus far have applied to patents essential to telecommunication standards such as 4G. However, they're becoming an area of concern in AI, where most standard essential patents at this stage apply to digital data processing, data recognition, or the transmission of digital information. In well-discussed telecommunications cases, such as Unwired Planet versus Huawei, which was decided by the UK High Court in 2017, courts have used disputes over domestic patent rights to shape the global business arrangements of private parties. Now, under the principles of lex protectionis and territoriality, patents are established under national law and have legal effect only in the issuing jurisdiction. However, the parties to these FRAND disputes are often multinational corporations with operations and patents in jurisdictions around the world. In a number of cases, often involving patent assertion entities or so-called patent trolls, which pursue predominantly Chinese technology forms, courts have specified the details, global details of FRAND licenses, including royalty rates that cover not only national patents, but also other patents around the world subject to the license's FRAND commitments. The result is a kind of non-coincidence of territory and jurisdiction, or what one prominent commentator on these patents calls the new extraterritoriality. Now, patenting strategies in artificial intelligence often take different form than those in telecommunications. Nathan Calvin and Jade Lung detail how firms aggressively patent artificial technologies in order to prevent other companies from suing them, while at the same time sharing these technologies in open source formats to attract research talent and consumers. Nonetheless, standard essential patents in artificial intelligence are concentrated in the United States, with South Korea and China being the next two countries on the rank. Although China is making moves to catch up, there's a geopolitical logic to these disputes. As Kan-Chu Liu notes, the litigious dynamics have mostly played out between standard essential patent holders in the US and Europe on the one hand, and major SEP implementers in Asian economies on the other. The willingness of national courts to issue anti-suit injunctions that prevent litigants from pursuing parallel SEP-related litigation in another jurisdiction has exacerbated this situation. For instance, in the 2018 case, Samsung versus Huawei, decided by the Northern District Court of California, Huawei was prevented from enforcing an injunction on Chinese standard essential patents, which was entered by the Shenzhen Intermediate People's Court. Now, it's very easy to interpret these disputes according to standard geopolitical scripts, where artificial intelligence advances are the object of rising great power rivalries. However, the extraterritorial and jurisdictional elements at play highlight the presence of other borders and struggles that belie this straightforward narrative. For a start, intellectual property arrangements can contribute to the making of patent thickets that make it difficult for smaller players to negotiate rights with multiple patent holders. The formation of patent pools, such as those that bring together standard essential patents, is frequently proffered as a solution to this problem of thickets. But such pools need not collocate patents issued by a single national or international body, and they may indeed include technologies that are unprotected in some jurisdictions. And this makes them complex and varied entities whose internal governance mechanisms are difficult to discern. So while there's a temptation to approach patent pools as price-setting cartels, the reality is more elusive. For instance, cooperation amongst patent holders may be driven more by promises of immunity from litigation than a quest for compensation. Some commentators present patent pools as a means for promoting ethical norms among AI developers. But the truth is that these entities are shot through with multiple borders, among which those that edge state territories are certainly prominent, but not alone. We need to approach patent pools not as devices of commoning or sharing, as the metaphor of pooling may suggest, but also as container technologies that separate out and make opaque the relations of power and capital that they perpetuate. And to this extent, they resemble the so-called dark pools of the financial world, the analysis of which, Donald Mackenzie writes, requires attention both to how money flows and how it is captured. So approaching AI through the legal and geopolitical frame of the patent pulls it down from the ether, where it seemingly hovers above and increasingly controls the social superstructure. However, patent law, or even law as such, cannot ultimately enclose the data and algorithms that impel this most recent iteration of capital's operating system. To the contrary, our analysis suggests that the patenting arrangements surrounding artificial intelligence tend to explode what Niklas Luhmann calls the formal closure of the law. Patents provide a point of contact between law and technological expressions of power. They can push law into the system of law and sovereignty from which Foucault argued modern forms of disciplinary and governmental power depart. However, given the importance of jurisdictional issues to patent litigation outcomes, they can also pull law into a frame of conflicts and overlaps in which there is no sovereign position to mediate between normative orders or even declare an exception. In this space, law becomes overstretched, potentially to the point where artificial intelligence decides its own rules. Thank you.
Thanks very much, Brett and Zoe. That was great to bring us out. So I'm not entirely sure how the session goes, but I think Kante now takes the microphone again.
That's right. Thank you so much, Ned and team, for a wonderful panel presenting what sounds like a fascinating project. Thank you for coming out in force to share this with us. So I will be moderating the Q&A both here on the floor at Jesus College, Cambridge, and online via our live chat. So whichever way you are participating, please do bring in your questions. Meanwhile, may I ask the first question to Anna and her team about PatentNet, where I saw in your graph that there seems to have been a collapse of the use of PatentNet from 2019 onwards. And I was wondering if you had an idea of what might explain that so suddenly after 2018, people seem to have stopped using this data set.
So the data set is from it's actually been provided by the Guangdong Intellectual Property Centre, and it's of patents from 2007 to 2020. It's quite possible that the later couple of years just weren't filled out as much. The actual data set's a slight mystery to us. I have requested a download or even a sample download, but I haven't been given any permission from the researchers who published the data set. I've gone onto the GitHub site, and there's not even a README file there, which is not untypical of GitHub sites. You know, people often push, or well, they commit things to GitHub and then they don't actually push anything to it at all. So that's not unusual. But yeah, so interestingly enough, also the data set seems to contain, from what we've been able to see just from descriptions on the GitHub site and from the PatentNet paper itself, mainly kind of fashion in industrial objects. And that also suggests to me that perhaps aspects of the Guangdong set has also been subdivided and used by other kinds of fashion AI models, of which there are many. So, from Fashion MNIST through to a number of other ones. And that kind of borrowing, sorry, I've got a terrible horn going in the background. That kind of borrowing and circulation of data sets is also something that we discovered when we were looking at the kind of provenance of terms and scientific kind of collaboration within that sort of expanded out from the PatentNet paper, which basically indicates that the Chinese researchers who put together PatentNet were on panels like this one at the very large kind of IEE computer international conferences that are held every year, often, in America, but sometimes in places like Korea or Taiwan. And so there's a kind of circulation of data sets and terms and material there as well. But why it drops off at that point, I couldn't tell you exactly.
No, but very interesting. Thank you. We have the next question from the floor here. Eleanor.
Hi, thank you. That was fascinating and a lot to take in. I'm particularly interested in patents, although know very little because of some of the industry work that my colleague and I are doing. And we're working with some of the biggest AI patent holders in Europe. And I was talking about what it means to be one of the biggest AI patent holders in Europe to a friend who works in AV. So he's an engineer making self-driving cars. And he was really upset about it, which I found really interesting. He said that it's a kind of bad practice. And he talked a lot, as was mentioned today, about patent trolling or patent hoarding. And so I'd like for you to kind of piece that out a little bit more for me. Because a lot of these patents really are kind of iterations of pre-existing things in machine learning with kind of slight differences. Nothing that's kind of completely new, but to kind of small differences. And maybe I guess in AV, a lot of stuff is open source, so a lot of the patents potentially are out there to help other companies develop similar products. So I don't know whether it's just a kind of industry-specific thing, but I'd really like to know your thoughts on that.
I can take that one. I think this kind of feeling towards patents, which most of us working in a critical vein would share with an AI developer, is quite widespread. If you look at the legal literature on patent pooling, patent thickets, even patent trolling, which is when you have a company that buys up a set of patents, often embedded in a standard, and then pursues legal cases in order to extract royalties from companies around the world. The big cases, as I said, have been in China. The standard kind of critical line in the literature is that these practices impede innovation. So our observation is that in making this critique of the patenting processes, the arguments buy into innovation logics, which of course are not themselves innocent of, economic motive, as we know from, I don't know, the work of Schumpeter, for instance. So I think that's a strong and valid observation, and it registers some of the tensions in the field. As I said, many AI developers will pursue a strategy of patenting their inventions in order to prevent litigation from other companies, but at the same time, they're sharing them on open source fora. That is a strategy they have to negotiate the situation. But I don't think any of these dynamics really get into the, this issue around jurisdiction and territory, which is, I think, where the more geopolitical logics of patenting begin to emerge in the legal landscape.
Thank you, Brett. Any further informations, further observations from anyone else on the panel? If not, we have another audience question. Oh, sorry, Zoe?
No, I was just going to make a note sort of about why patent trolling is sort of such a concern with AI. I mean, it's sort of the more complex a technology is, the more sort of layered the componentry, the more susceptible it becomes to trolling, in part because those patent thickets become kind of like more like dense, harder to unpack. And so the trolling, you can have a patent for a very kind of fundamental, even like minuscule aspect of, like a larger technology being protected by a particular patent that has to be licensed in order for a more complex piece of technology to be used. So I think one of the reasons why AI, trolling might not have been a kind of condition of concern prior to things like telecoms, and now that we're in kind of increasingly complex spaces, you find yourself in a position to be more and more kind of trapped by these matters. And so I think it was just to clarify that point about why we might find trolls in AI patenting.
Thank you very much. I've switched to this one to make sure that I properly see everyone as you raise your virtual hands or otherwise indicate that you'd like to participate. So we have an audience question here.
Yeah, thank you so much for this panel, because I really enjoy all your talks and your investigation on patents. So my question is, how do you think that the global shortage of geological materials like gas, petrol, and other minerals to build like technological artifacts, and also like the supply chains problems that we're seeing around the world, will impact on the geopolitical of automation?
That's got to be.
Arit, how do you feel about handling that one? It sounds right up your territory.
Sure. Yeah, especially because I'm in a mining. I'm actually in a mining zone in northwestern Quebec right now, where they're looking for rare earths and lithium. I think you pose a really interesting question about assemblages and how older historical and material questions overlay or perhaps intersect with kind of these newer epistemes that I think are being detailed here. I'm a historian, so I don't tend to make predictions, but I think obviously the kind of acquisition of those materials is extremely localized. It is really particular geographically. However, I guess, so one of the questions is whether it'll kind of affirm a kind of reactionary nationalism, if you will, in relationship to these new, like more fluid systems. And then the question is sort of how the two are going to negotiate each other and what new kind of political or geopolitical entities are going to occur. So I tend to think around extra statecraft as a kind of idea here, where you could see a confirmation or reassertion of kind of national security and national concerns, while at the same time, those same interests might be also aiding or abetting particular corporate entities. So I don't know if that's an answer, but I think it's sort of like a coming into being. And there's then also the reality that, at least from a minerals perspective, I don't know that much about oil. You know, these are global corporations that have their own supply chains that reach way out. Like, no Canadian mine is just a Canadian mine. I mean, every one of those companies operates across Latin America and often Africa as well. Same is true of Australian mining conglomerates. And so there's an interesting issue there, where both there's this renationalization, while at the same time there's this new kind of colonialism, I guess, where, you know, people are strategically seizing territory elsewhere as part of ensuring the security of their materials and their supply chains. I don't know if that's an answer, but I think it's an emerging situation that both has us have to re-engage with maybe the geopolitics we want to throw out, but at the same time, it's not an exact direct return to older forms of nationalism because of the way even the mining industry is now organized logistically, globally. I don't know. Ned, do you have anything to say?
Thank you, Reed. That was really insightful. Anyone else on the panel would like to add to Orit's observations? Yes, Brett?
I won't pick up on the, you know, the geological and the mining part of the question, apart from saying that you know, the issues of extraction clearly apply to data as well as to the biosphere. However, in looking at the supply chain management literature that's coming out in the pandemic, we're starting to see some shifts in mathematical modeling that I think are relevant to, you know, the automation of supply chains and how that might shift. You know, what we hear all the time is the pandemic has meant that supply chains have to shift from being efficient and lean to being resilient, from just in time to just in case and so forth. But the supply chain literature is now talking a lot about mathematical models of viability, which are, you know, they draw on cyberneticians such as Stafford Beer and Jean-Pierre Aubin's 1991 book, Viability. You know, there are different kind of species or iteration of model. So if you're interested in following it up at that mathematical level, I think we can see shifts that may become relevant to automation routines in supply chain management and kick on into geopolitics.
I would add to that like, just from work here on full automation and the way people are hoping to use AI and mathematical modeling to actually extend life cycles of mines. And I mean, there's also like a real materials feature right now where people are trying to eke out or resurrect or rediscover new materials out of using kind of ever enhanced ideas of optimization and new mathematical models, essentially, of geology and of ecology, actually, because questions, of course, of impact, toxicity, and very often viability actually comes up a lot in the mining literature as well.
Indeed.
I wonder, in the short time we have, I wanted to sort of recast the panel discussion a bit where we've had this framing in the panel overall around geoeconomics and geopolitics. But one of the things that struck me in Tsvetelina's talk on AI and machine learning systems that recognize the where in fashion items, that then get returned. It struck me that, what they're coming up against there is the question or problem, if you like, around cultures of wear, like how do people wear clothes? At what point does it register as something that's deteriorated? And how does this sort of distinguish itself in ways that aren't captured by this very limited set of parameters that the machine learning system is using? Tsvetelina, do you know anything on that side of things, or have you got any thoughts there?
Well, the example that was given here in the presentation was from Google, but actually Alibaba is a big leader in developing this kind of image recognition technologies, especially for the purposes of retail, where the idea is that customers can just, if they see something they like, they can easily snap a shot and then find through the image recognition software and the application that they have on their mobile where they can buy it. So yeah, this is what I've got to say, actually.
Well, thank you
where
so much. Sorry.
I was just going to say that there's new tech really that, like, there are virtual dressing rooms that are now being piloted by Amazon in physical stores and in new department stores, that are allowing you to essentially to wear and for Amazon to learn from how you wear. So yeah, it's an interesting point.
Yes, absolutely. And I think that's an excellent way to announce that the next panel in our conference will be on AI, fashion and style. So that was a perfect transition from the panel on geopolitics and patents to fashion, which I didn't know was possible. And I've been looking for that bridge to announce this break right now. So thank you for doing that for me. So with that, I would like to say thank you so much to all 7 of you for taking the time to come and attend at what for us is a perfectly normal time of the day and for you is not, to share your work, this fascinating project of which it was brilliant to see all the different angles, and we look forward to seeing where this goes from here. Those of me with me in person, please join me in thanking the panel for their contributions. Thank you.
Thank you very much for having us in your program. We're really glad to be part of this conference and look forward to the evening.
Thank you very much, Ned. And for those of us Hello and welcome to our final panel of Critical Borders. I can't believe how the time has flown by and how many people have been joining us virtually, as well as our core group in person in Cambridge right now. This final panel is one that we convene out of seeing a range of abstracts being submitted that all converged around a theme of art, fashion, and style that we have put together under the banner of AI and aesthetics. We have got 4 incredibly exciting speakers on this panel today, and I will now hand over to the chair for this session, who is joining us virtually from Berlin, my colleague Indira Ganesh.
Hi everyone, good morning, good evening. Thank you so much, Kanta. I'm absolutely delighted to be chairing this panel and this session. I feel like there's never enough discussion of style, art, fashion, and aesthetics when it comes to AI, and I'm definitely looking forward to the papers in this panel. So just as an order, a point of process, we're going to go in the order of Gilles, Linda, Sophie, and then Ralph. Each speaker will present for about 15 minutes, and then we will have time at the end for questions. So make sure that your questions come in through the appropriate formats, either online or offline, and Kanta and Tony will filter them through to us. So without further ado, I'm going to hand over to Gilles, who will be presenting first. Gilles is in the 3rd year of his PhD in quantitative economics. He's passionate about using mathematical and computer science tools to solve real-life problems. He profoundly believes that AI can bring many answers to humanity's evils, but only if it is inclusive and respectful of human values. Thank you, and over to you, Gilles.
Thank you very much. So I'm very glad to be here. So my name is Gilles Hacheme. I'm going to briefly present a work I have been doing with Noémie Sayouti, that is my co-author. We co-founded together AI for Innov. That is a non-profit organization that is working for inclusive AI. So I'm going to talk about neuro-fashion image captioning, accounting for data diversity. So briefly, what is image captioning, neuro-fashion image captioning? It's simply the automatic generation of descriptions from images. So here we're going to focus on fashion. So the question is, why fashion? Why are we caring about fashion? So fashion is a very growing market that's going to worth more than $2 trillion in 2025. And currently, what is noticed is that most of the technologies, AI technologies developed around fashion is Western center. And there is like an exclusive view of the technology, the AI technologies currently around fashion toward Western style. So that's why we decided to work on a project that we name Infash AI. Infash AI is simply inclusive fashion or artificial intelligence. And the first thing we want to do is building data sets that includes African fashion, because most of the data sets that are available today are completely missing the African fashion. And so we developed a first version of this data set called Infash V1. That's the first African fashion style data set, including images, titles, prices, and general descriptions. And this data set is rather limited to almost 16,000 data points, but it is a first step toward building bigger data sets. So in this work, we use these data sets about African fashion concatenated with another major data set, that include Western style called deep fashion, that is well known in the literature, in order to leverage the bigger, the fact that the deep fashion data set is bigger, and in order also to be able to get some potential transfer learning from the Western data. So let me talk about briefly some related work. So fashion has been a major topic in computer vision, and there are lots of studies around it. And it includes studies about fashion detection, fashion analysis, fashion synthesis, and fashion recommendation. Here we focus on fashion analysis and especially fashion image captioning. So there are several ways in which the captioning can be done. When I'm talking about captioning here, it's simply about detecting the attributes in a very specific way. There are two approaches generally in the literature. You can do it using a multi-level classifier, or you can do it like a text generation task where you give an image to your model and it generates a text. So we using the second approach here. The way it goes is that you have an encoder decoder like model where your encoder is made of a CNN and your decoder is made of a recurrent neural network. The first major work that have been done is the one by VIII and co-authors in 2015, and I would say the backbone model is the show and tell one, and as I was saying, it is made of CNN and RNN, and we can replace the CNN by a pre-trained CNN like ResNet that has some pre-trained, I would say some information, some general like informations that we can use to train our own model. So let me go quickly to the next slide. A big motivation of what we're doing is ethics and especially inclusiveness. I was talking about the fact that the fashion market is growing very fast. If the fashion AI tools are like exclusively Western, what we're going to notice is that it's going to be always only in the advantage of the Western fashion, and the other types of fashions like the African ones are going to be excluded, and it is a rather it is, I would say, an economic problem. So here we want to be inclusive in building on AI that is more general, that is less biased, and where should we start? And I do like this declaration in the work of Shu and Kaufer that say that the most critical step in creating inclusive AI is to recognize where and how bias infects the system. Indeed, when you build some AI systems that are like exclusively focused on one direction and is, I would say, don't care about other directions, it will directly affect this performance of your system, and at the end of the day, you will end up with a technology that's less generalizable. So the first problem is the data sets, and just as an example, if you build an algorithm that learns from on a face detection algorithm that only learn from a data set in which you have a given types of skin and other colors, other skin colors are excluded from this data set, you can't expect your algorithm to generalize well to other schemes. So these same concerns also is also involved in fashion AI. And you have data sets like fashion MNIST, deep fashion landmark data set, and others that do not include the African fashion. This is majority, I would say this is very likely due to the fact that African web platforms are very missing. When you look at the internet, you won't find so much African fashion web platforms. And so we have in mind, okay, we have this constraint of data. How can we deal with that? How can we go and find data sets about African fashion? What we did is that we look for, first, some African web platforms that exist nowadays. And the first one that we found is Africrea. And we try to collect data from that using crowdsourcing methods. And we arrived to almost 6,000 item images. But I would say our goal is not to train a model that will only recognize African images. So we also use here in our model of a deep fashion, a restricted version of a deep fashion data set that is made of almost 80,000 images. So including gender, color, sleeves type, and garment type. The data set that we collected for the African fashion is something, it wasn't really like standardized as a deep fashion one. So we made on annotation work. We did some filterings, and after that we get, I would say, like almost 9,000 images after some filtering and after annotation. We retain only those images to train our model. And what we want to verify here is, should we use only African images to recognize African styles or African like fashion images? Should we use it in concatenation with Western data or not? And this is a question we want to answer. The model architecture, I won't spend too much time here. It is made of CNN and a sequence of LSTM here, and we just encode the image and we decode it through the LSTM, generating at each step a word. And in the sequence, we have the attributes we are caring about. So just briefly, our results. Here we have a table presenting the blue scores in different configurations. So you have here, we have a trained data set like that is including only African. And what you can notice is that when we test it, it is better on African data. Oh, I forgot saying something. Increase, better is the blue score, better is the model. So here you can notice that when the model is trained on African data set, it performs better on African images. That's quite normal. And when it is trained on Western images, it performs better on Western images. But you can notice that the data gap implies a kind of positive effect on, how can I say it? We have a better score on Western data. You have 0.66 as blue score compared to when we test the model trained on African because of the data gap. Okay, so as soon as we add just a bit of like the half of our data set, the African data set, we can notice a major increase on the blue score. You can see it that when consider the third line, when we have trained Western plus half African. The test on African is already better, and the result on tests Western is stable. Okay, and the result is comparable when we use all the African data set. And this is simply implying that we can just add a bit of some diverse style to have a huge improvement on our results and on the model capability to generalize. And we have similar trends when we use also F1 scores on each attribute, on gender, on attributes, on color, etc. So to conclude, we introduce here the InFash AI V1 dataset. That's the first one, including African fashion. And we use the show and tell model to train a model, and we show that including at least a bit of like a diverse styles can hugely improve the generalization capability of the model. And we also say that using jointly the African dataset and the Western dataset results in a better model compared to using only the African one or only the Western one. So we call for more work in that direction, and we hope that other works will build in top of this data set and will eventually improve it and have results that are more impactful. We hope so. So next steps today we have a model that can that can detect the gender, the color, the type of slave, and the type of garments. But we want to go further, and we're working in partnership with the first African web platform in fashion called Africrea, and they are giving us access to the data set, to a huge data set that we're working on currently to go further and to detect other attributes like the fabric or the type of occasion in which the garment can be wear. So thank you very much. If you have any question, don't hesitate. Thank you.
Thank you so much, Gilles. It's always really fascinating to hear these hear papers that show us how deeply culture and technology are shaping each other. And on that note, I'm going to hand over next to our next speaker, Linda, who's going to talk about classifying humans, representations of machine vision in digital art. Linda Kronman is a media artist, designer, and currently a PhD candidate at the University of Bergen, researching how machine vision is represented in digital art as a part of the Machine Vision in Everyday Life project. And as part of the artist duo Kairos, she has been producing art on topics as diverse as surveillance, smart cities, IoT, cybercrime, and electronic waste, amongst others. Thank you, and over to you, Linda.
Thank you, Maya. So as Maya already in the introduction said, that I'm a PhD candidate at the University of Bergen in a ERC-funded project called Machine Vision in Everyday Life, led by Jill Walker-Redberg, who is also present at the conference. And my focus in the project is on digital art. Therefore, in this presentation, I will use artworks to discuss the topic of classifying humans, referring both to machines classifying humans and humans who classify. So Jeffrey Boker and Susan Lystar examine classification systems as infrastructures in their book, Sorting Things Out, Classification and Its Consequences. Their introduction declares, to classify is human. They continue by exemplifying how classifications have consequences advantaging or damaging individuals or groups. Classifying is also what artificial intelligence does. This paper explores how AI-powered machine vision is used to classify humans and how automated classifications are shaped by shaped by assemblages of human and technical cognizers. So my research is informed both by quantitative and qualitative interpretations of contemporary digital artworks in our machine vision database. For the machine vision database, our team collaboratively have collected 500 creative works. This includes novels, as narratives, movies, digital artworks, and games. And all these works, what they have in common is that they either represent or simulate machine vision. Each of these creative works is linked to one or more what we call machine vision situations. In these situations, we use verbs to describe what machine vision technologies and other actors are doing. So if on the screen you can see the example of Mimi Onuoha's classification 01 work, in this machine vision situation, the visitor approaches the artwork and is classified by facial recognition software. Different algorithmic measurements are used and the result is then compared to the previous visitors. And if both visitors are classified similar, two neon light brackets light up. So who does what in this situation? This is how we describe it with the verbs. So the entity user, in this case, the visitor, is approaching, analyzed, classified, compared, and watching. The technology, facial recognition, is capturing, analyzing, classifying, and comparing. And the entity, the object, in this case, the neon brackets, are signaling. So in this way, we have analyzed 893 situations in the database. So if we then look at the most used verbs from all machine vision situations, both classifying and classified are in the top 10. And notably, the verbs classifying and classified appears more often in the collected artworks than in the other types of creative works that we have in the database. So if we then look at who is then classifying, we use the label classifying to indicate the act of organizing according to class or category. And AI-powered machine vision like facial recognition, object recognition, emotion recognition, and machine learning are the technologies most often described by us to be classifying. And the act of classifying is performed by humans 14 times. Who is then classified? Those classified, in other words, divided into classes, are most often humans. As presented here, in a nutshell, taking a closer look at artworks in which machine vision is classifying humans can provide us examples to understand the politics of classification in AI. And as Kate Crawford writes in AI Atlas, the politics of classification is a core practice in artificial intelligence. Further, all the creative works in the database are labeled with one or more sentiments, describing the dominant attitude represented toward machine vision. If we compare the sentiments of all the works in the database with the creative works linked to a situation containing the verb classifying or classified, we can see some differences. Works containing situations with classifying or classified are more often described as flawed than helpful, which is the most used sentiment in machine vision, in the machine vision database. So one example of flawed machine vision is How to Be More or Less Human by Max Zoe. In the performance, Zoe, dressed in a suit, is posing in front of a web camera. He attempts to be identified as male by the image recognition software. As long as Zoe is dressed, he is recognized as a man. However, when he starts undressing, he crosses a border and his body is classified as a woman. The misgendering caused by increasing nudity exposes a bias towards naked bodies being associated with women. Further, the performance highlights the ideological borders created when machine vision is sorting humans into the binary categories of woman and man, excluding any other gender identification. Artist Joy Buolamwini is known for intersectional auditing of gender classification products. In her video poem, Ai and I, a Woman, Buolamwini demonstrates how iconic Black women are repeatedly misgendered when classified by facial recognition technologies. In the Misgendering Machine paper, Oskis writes, 30 years of research has not produced a single system that can genuinely recognize gender. It has only produced systems that try to assign it. And as Michel Elam's talk yesterday demonstrated very well, the ambiguity of race and the problematics with machine vision assigning race or ethnicity to humans. Further, the Western colonial gaze of machine vision, which Gilles' presentation also was demonstrating, machine vision both assigns and erases identities. Salaf by Neuf Al-Jawazi is an expression of this. Neuf was using object detection software to classify images from her ancestral archive. However, images of her ancestors wearing traditional clothes were repeatedly misclassified as military, army, or soldiers. Hence, she used a segmentation tool, removing each stereotypically misclassified person from the images. This new dataset was then used to train an AI model generating images manifesting the erasure of her ancestors' collective memory. To some extent, increasing intersectional and cultural diversity of the datasets might improve the accuracy of machine learning models. However, the question remains whether a person's gender, race, sexuality, or other identity attributes can be read from one's body. Companies like Faceception take physiognomy, the practice of assigning a person's character based on their outer appearance, to another level. They claim to be able to score individuals according to classifiers such as terrorist, professional poker player, or academic researcher. Recent research also claims that machine learning models can be trained to recognize criminal or gay faces. Both fascinated and critical of such claims, Marta Revuelta and Laurent Weingart created an artwork, AI Facial Profiling, Levels of Paranoia. In this interactive installation, mimicking a security control situation, the visitor's face is scanned with a gun-like device. Thereafter, the captured image is classified, either posing low or high risk of threat. The high-risk classifier is trained on images of gun users scraped from YouTube, and the dataset of selfies is used to define the category of low risk. The automated judgment is stamped on a document moving along a blue belt. And the normalizing machine by Mouchon Zeraviv takes a historical approach by referencing to Alfonso Bertillio's Le Portrait Parlé, a pioneering forensic system for categorizing faces. The statistical system was later widely adopted by the eugenics movement to criminalize the face. Normalizing machine asks the user to classify who looks more normal. The work speaks about the dangers embedded in classifying humans. If a system is trained on what is normal, it will also recognize what is abnormal. Ian Hackings describes what happens when humans are classified in medical sciences. Sometimes our sciences create kinds of people that, in a certain sense, did not exist before, that is, making up people. In a sense, machine vision technologies are also made up make up people through the classes and categories they embed. The practice of naming those categories and classes are done by classifying humans. In other words, those humans involved in assembling data sets for machine learning. In the database, 14 times humans are described to be classifying. Many of those situations are exposing the often hidden work of assembling data sets. One of them is suspicious behavior, a fictitious data annotation tutorial that I was co-creating with Andreas Singele. By traversing the introduction and 3 advanced hit models with the task of labeling suspicious behavior, the user experiences aspects of annotation work and what it embeds to train smart surveillance cameras. Suspicious behavior recreates through video montages and human intelligence tasks the work of annotators, which Nicola Maleve describes as follows. The workers, if they want to make a living, need to work at a pace that barely allows them to see the images. For the annotators, structurally, the glance is the norm. However, decisions made in a glance are shaped by the affordances and restrictions of a given annotation interface. For suspicious behavior, we developed an interface showing 1 video at a time. The annotator is restricted to decide whether the situation is suspicious by hitting a yes or a no button. A similar user interface was used by the creators of the MIT Moments in Time dataset. This type of interface gives no possibility for comparison. In the beginning of the suspicious behavior tutorial, an interface familiar to many of us asks the annotator to select the images with a given motive from a grid of images. A leaked image of the Amazon Rings annotation interface affords the tagging and tracing of moving objects in the video. The user interface interplays with the efficiency and the accuracy an annotator is required to perform. The advanced model, Speedmaster in Suspicious Behavior, simulates this experience of optimized decision-making. In the end of this 1-minute module, it is determined whether your accuracy and speed would guarantee more work for a living wage. Another advanced model reveals how complex human behavior is reduced into banal categories of animals and normal behavior. These categories are from the UCF crime dataset used to develop a model to detect high scores of anomaly in video segments. Even before the annotators are assigned to label a dataset, the categories are defined and images collected. For example, the UCF's crime videos were scraped from YouTube and LiveLeak using search queries like car crash or road accident for each anomaly. The keywords, what is circulated on a platform like YouTube or LiveLeak, and the search algorithm all play a role in what videos end up in the dataset. This is what Flavia Saxler was talking about yesterday in context of open source intelligence and how search queries have their biases. Further, like Ruha Benjamin in her opening lecture pointed out, we need to raise questions of who is defining these categories and what values do they embed. According to the developers, these anomalies are selected because they have a significant impact on public safety, but safety for whom? In Data Feminists, Catherine Ignacio and Lauren Klein argue that data must be classified in some way to be put to use. What I want to demonstrate with these brief examples is how not only annotators, but developers, search algorithms, and the platforms are part of putting data to use. As demonstrated, the artworks in machine vision database fill some of the data feminist principles as they examine power, rethink binaries and hierarchies, and make labor visible. This video from the machine vision exhibition at the University Museum in Bergen, where a collection of artworks from the database was used to tell an alternative dominant narrative of AI-powered machine vision. In several exhibitions, digital artworks are now playing an important role in debunking myths of neutral or superior AI for wider audiences. Understanding consequences of classifying humans and how humans classify is a step towards revisioning AI. Thank you.
Thank you so much, Linda. We're going to move on next to hearing from Sofie Vlaad. Sofie is currently doing a PhD in philosophy at Queen's University in Kingston, Ontario, Canada. And we're really happy that you can join us. We know it's early in the morning there for you. Her research is firmly rooted in the feminist philosophy tradition with a focus on developing a philosophical account of trans poetics. Sofie's paper today is titled, Do Androids Write in Electric Verse? Poetry, AI, and Science Fiction.
Just screen sharing. Technology is great. Okay, just gonna set a timer. So yeah, I'm trained in philosophy and not computer science, so it's gonna be a little different. I'm gonna talk about Star Trek and poetry, so hope people enjoy. Originally, this was more of an English paper that kind of got transformed into a philosophy paper / AI ethics paper. So I guess sort of these three motivating questions for this presentation and others I've given, sort of just who is the general audience, because I'm still not sure directly to whom I'm speaking in the paper. How well does it flow between section and topic, because I give a lot of different examples from different areas. And then are there additional examples I could point to, especially with regards to sections on contemporary AI and art in poetry, poetics. So I was going to play a short clip. I don't know if that will work. If I share my sound. Probably won't play the whole thing, but give you a sense of what I'm talking about.
Poets have composed odes to individuals who have had a profound effect upon their lives. In keeping with that tradition, I have written my next poem in honor of my cat. I call it Ode to Spot. Felis catus, is your taxonomic nomenclature an endothermic quadruped, carnivorous by nature? Your visual, olfactory, and auditory senses contribute to your hunting skills and natural defenses. I find myself intrigued by your subvocal oscillations, a singular development of cat communications that obviates your basic hedonistic predilection.
So the rest of the poem goes on like that. The crew of the Enterprise tries to get Data to stop. He keeps going. So Data's an android, so it's a humanoid robot from the fictional Star Trek universe. And in this episode, he writes the poem to his cat. And so the general sense is that the poem is bad, it's not good, robots can't write poetry, and the audience is meant to identify with the crew. It's like a humorous moment. So while there are no robots like Data in the real world, we do have rudimentary machines and artificial intelligence. So we can think of them as proto-data, so different from the sci-fi context, but still we use, computers, IRL. And so in this talk, I'm just going to show some examples from digital poetics and computer art, digital art, and show how, as the technology seems to progress and develop, the use of machines as mere tools and machines as potential creative collaborators, this distinction starts to blur and break down. So then I turn to science fiction to imagine how we might articulate those relationships. If we are to give that there's at least a chance machines might be, or AI in particular, I'm thinking of like GPT-3s and deep learning and advancements in that area. How we might, if we consider them collaborators, how do we understand sort of autonomy and ethics, and what kind of collaborators do we want to be involved with? Or do we want to create?
For a rhythmic
Digital poetics. So I'm just going to briefly go over digital poetics. It's sort of a field of poetry that coalesced at the end of the 20th century using technology, hypertext, the internet to produce poetry that's either uses technology in its production, such as this, which is a piece by Danny Spinoza, or is completely online. So this piece is called Christian Book. It's a glossa, which is sort of a citational poem, and it was made using a typewriter, citing a line from another poem, and then uploaded to Photoshop and then transformed in such a way. So this seems to be a case where the technology deployed typewriters in Photoshop as clearly a tool, but it gets more ambiguous the more we look at it. So Aaron Murray in the late 90s used Mac Prose, which is a freeware software that randomly produces text based on syntactical inputs. So she would input something and text would appear, and then she would use that text in her poetry. So again, kind of like a tool. Then there's Christian Book and the Xenotext project, wherein Book encoded a poem called Orpheus into DNA, inserted the DNA into a bacterium. The bacterium transcribes the DNA into RNA. And if you use a cipher, the RNA is a different poem called Eurydice, Orpheus and Eurydice. So in this case, I think it's more ambiguous as to who is doing the work of composing or enacting or creating the poetry. So like a lot of the back end was done by Book and other scientists, but it seems as though the bacterium is involved. We might think of this as a biological machine. So contemporary AI, you know, it's not exactly data from Star Trek. So machine learning in particular has several weaknesses depending on how long the string it produces is. You lose semantic coherence. Machines don't necessarily differentiate between fact and fiction, so you end up with untrue facts. And there's lots of bias, which the other presenters have alluded to. I don't know that I need to unpack machines and bias, but I'm going to do it anyways. So Microsoft introduced an AI called Tay onto Twitter. And so Tay was a program where the data set was Twitter, and then was the language model that produced tweets. And very quickly, Tay adopted what might best be described as genocidal views. So yeah, I don't think we'd want to collaborate with Tay, and that's the limitation of AI. It's only as good as the data sets and the biases of the people who create it. I'm interested in GPT-3s and deep learning. So general pre-trained transformer. So deep learning is a specific kind of machine learning. And it's a language model that has shown success in generating art based on data sets or creating lines of poetry or fiction, science fiction, that kind of thing. So this section was going to be focused a bit more on the blog AI Weirdness, which is created by computer science researcher Gilles Hacheme. It's moved in a little bit of a different direction, but I have some examples of people using GPT-2 and other kinds of machine learning to produce art. So the Tulips are an artwork by Anna Ridler. And so it was created, so she had a data set of hundreds of tulips, and then she used GPT-2 to assess that data set and generate a tulip that changed depending on the value of Bitcoin at the time. So it was a critique of capitalism, but in that case, it seems even more ambiguous than the book case, where it's like, who is doing the work of actually creating the tulip? What contribution does the AI, does the machine learning contribute? And yeah, another example would come from Robin Sloan, who's a science fiction author. He uses a modified predictive text to, so he'll write a sentence and then the autofill will write the next sentence and he'll keep it in the novel and then just keep writing that way. So to me, it seems as though it's not just Sloan who's doing the writing. There's something else going on there. So how can we think of AI as collaborators, or how can we think of AI otherwise? So in this section, I wanted to turn to science fiction to kind of imagine possibilities. So I'm not going to spend too much time here, but Margaret Ree, who's another poet, has a collection called Love Robot, wherein she reimagines robots and AI, not as tools or as machines, but as lovers and collaborators. So there's some like erotic imagery between a narrator and a robot, told from both perspectives. Ree also writes the poem wherein she imagines a robot writing a love poem. So which is kind of the question going back to Data's ode to Spot. Can a robot write a love poem, or can AI write a love poem? And if not on their own, we might imagine cases where there's some collaborative input happening. So I also turned back to Data from Star Trek, specifically the episode Measure of a Man, where Data goes on trial to prove if he is the property of Starfleet, which is the organization he works for. He wants to resign because he's being forced to undergo an experiment that will take him apart to build more Datas. The prosecution argues that Data is property because he's a robot, a mere machine, he's not sentient. And the defense, Captain Picard there, Patrick Stewart on the screen, argues that sentience is actually irrelevant and we ought to think ethically how we treat others, and generating a whole species or race of Datas to use them for like labor and menial tasks seems to be an injustice. The comparison made in the show, it's late 80s, is the comparison is to slavery, but take from that what you will. But the idea here is that sentience is not necessary for autonomy in this case. And so moving forward, I want to think through that question a bit more. I mentioned earlier, this started as kind of an English paper. So there was a very different thesis involving, contemporary discourses surrounding digital poetics. Now I think I want to focus more on the AI ethics side of things. So we have these cases where machines might not just be tools, they might actually be contributing to the creative process. So what kind of machines do we want to make that if they're going to be creatively contributing? So I think back to Tay, the Microsoft Twitter bot. I wouldn't want to make art with Tay, the genocidal AI. So yeah, I think next steps would be probably to write a philosophy section, considering I'm trained in philosophy, to focus on an account of autonomy, like a relational autonomy that links to relational ethics. I know people like Brihane have developed relational ethics accounts with respect to AI. So yeah, thinking about there are like practical and material ways in which we ought to consider the effects of AI, but there's also sort of aesthetic and creative ways in which the design of AI might be important. So yeah, so I welcome any and all questions, very much a work in progress. So, but that's what I have for now. Thanks for listening.
Thank you so much, Sophie. And just to remind people watching online, but also offline, to please start thinking about the questions that you have for our panelists as we move into the last presentation today by Ralph Borland, who will be talking about Village Oracle and XR experiment, art experiment in envisioning AI. Ralph is a South African artist and researcher on AI in Africa at the Institute for Humanities in Africa at the University of Cape Town. His work is frequently at the intersection of art, technology, and social activism, and his work is in the permanent collection of the New York Museum of Modern Art and is selected for the Dakar Biennale 2022. Over to you, Ralph.
Thanks very much. 。 . 。  . 。 . 。 . 。 .
. . . . . . 。 . 。 . 。 . 。 . 。
。 . 。 . 。 . . 。 . 。
. .
。 .
.
。 .
.
Great. Hi, everyone, and thanks to my fellow panelists. So this project, Village Oracle, is an artwork proposal, and I'm going to contextualize it by talking about some of my prior work. As Maya mentioned, I'm at HUMA, the Institute for Humanities in Africa, a Pan-African research station in Cape Town. And I'm using interdisciplinary approaches to investigate AI in Africa. So this is about a proposal for an artwork that lives in shared virtual reality on the platform Virtual Reality Chat, VRC, where I have previous artwork. This is just a little screenshot of a mock-up where you see a character looking at this wall of black and white orbs, which is a cellular automata-based artificial intelligence. And I'll talk to you about that. But to contextualize the work, this comes out of my work I've been doing for the past 7 years or so on a project called African Robots, where I work with street wire artists in Southern Africa, men who make objects out of wire on the streets and sell them to make a living. I've been collaborating with them to bring interactive electronics to their work. So this is a little robot bird that we made together back 6 years ago or so that moves around and flaps and makes sounds. This is another little bird we made called a crested barbet. And this is a shot of a marketplace in Mozambique and Maputo where wire artists and I are working together on a funded 1-week workshop where we're looking at ways of using mechanics and electronics to make different kinds of wire art. So it's about collaborating with a vernacular art form that already exists and sharing technical knowledge. So I have a background in fine art and in interactive electronics. And so I bring some of my skills and they bring their skills, and it's about democratizing access to technology and making new forms of art, street level art. We have a side wing of the project called Spacecraft, where we make science fiction models out of wire that play on the idea of the wire frame. So old school computer graphics, like I grew up with in the 1980s, showed 3D objects as wireframes. And so there's this idea, this almost like a visual joke or a visual pun of making real objects out of wire. So just to be clear, these are real objects that look a bit like wireframe renders and made with this vernacular street wire art style. And this is a larger scale installation. This is Louis Kaluzi, one of my collaborators from Zimbabwe. And we've made this big installation with lighting and text scrollers and all of these like Star Wars spaceships. African Robots and Spacecraft together collaborated on this project, which was hanging in the Zeitz Museum of Contemporary African Art in Cape Town in 2019. It's called Dubship 1 Black Star Liner, and it's a 6-meter long, half-ton spaceship sculpture that has an electromechanical music-making system inside it, and it plays the dub track Black Star Liner. And the project plays on the history of Marcus Garvey's Black Star Line shipping company that operated a century ago from 1919 till 1922. And Marcus Garvey was intent on returning the descendants of African slaves from the diaspora back to Africa through setting up a shipping line. It didn't last very long, but in dub music, there are many tracks that remember Marcus Garvey's project and still imagine that the Black Star Liners are coming to Jamaica to take people back to Africa. And we produced this work and exhibited it on an Afrofuturist show where the ocean-going ship becomes a spaceship, and it's about this urge to leave Earth or to find other spaces in the face of Earth's history of injustice. So this has got a dub sound system inside it and a music making system inside it. So in 2020, during the COVID epidemic, we got funding from the African Culture Fund to take the dub ship into virtual reality. And this is our existing work on the platform VRC, or Virtual Reality Chat. And Virtual Reality Chat is a space in which people can meet each other wearing their VR headsets or even just using their computers and monitor and keyboard. But you go and visit these fabricated 3D worlds that, if you're wearing your headgear, are as if you're inhabiting these spaces, and you see other people as avatars in these spaces. So you can go in there and you can go and look at the spaceship. We 3D scanned the dub ship and we produced an animated model of it. And then all of these funny cartoon characters you can see in this space are actual people who are all inhabiting avatars, and they're all like checking out the sculpture and socializing with each other. So the space is called DigiDub Club, and it's a social space that revolves around the artwork, and it's a space that people can socialize and meet each other in. I've written about the work. This is from the Journal of Futures Studies, plural. So Futures Studies, fascinating field that looks at the idea of contingent futures, how futures are interpreted from different perspectives. And so I wrote about spacecraft as a Southern interventionist art project using futures studies as a lens. So you can look this up. It's open access on Journal of Futures Studies. And now moving into the future, the imagined future, which is a proposal for an artwork that's another African robots and spacecraft project. What this depicts is the idea of a sculptural wall. So this would be about 4 meters by 2 meters, 4 meters wide by 2 meters high. A wire art framework that contains these revolving spheres that are black on one side and white on the other in the sculptural version. And what they do is they play a cellular automata across them. So I don't know if all of you out there know what cellular automatas are. You probably do. I've been fascinated by cellular automatas, especially the classic Game of Life, Conway's Game of Life, for a long time. It's basically a system. This is a close-up of how the wire art sculpture would work. It's basically a system by which squares on a grid are set to be either alive or dead, and if you like to think of it that way, as artificial life. And then they have rules that if a cell is overcrowded, it dies. If it doesn't have enough neighbors, it dies. If it has just the right number of neighbors, the cell will come to life. And then you run multiple generations on a grid, and you get the effect of motion and life, like pond life, or bacteria on a slide. Here's a little animation of a classic Conway Game of Life sequence. It's called a gospel glider gun, is one of the configurations. So cellular automata are expressions of complexity, the idea that you can give simple rules to multiple objects, and when they interact with each other, they produce complex behaviors. And so people have been working with Game of Life since the 1950s, experimenting with different forms that you can seed the board with, and then you get different animations out of it as a result. And actually, this cellular automata and the Game of Life, Conway's Game of Life, was based on his observations of Go, and he used a Go board, the board game, in order to do his prototypes. So prototypes of Game of Life used Go counters on a grid, and then he'd manually turn replace the counters and produce these generational effects. And you can see the principles of complexity in Game of Life in things like murmurations of birds, like migrating birds who produce these complex forms, or fish. Basically, how fish and birds navigate is they have simple rules that say, keep this far from your neighbor to the right or the left, keep this far from the person in front. If this happens, do this simple action. And then collectively, you get these incredible overall patterns as a result of these simple rules. And Game of Life is a simple example of a cellular automata, but with much more complex multi-dimensional cellular automatas, you can produce true computers, and you can produce computers that can do artificial intelligence or machine learning. So as well as Game of Life being a kind of artificial life, it can also, cellular automata can be used to make artificial intelligences, which is the gesture that brings me to this artwork proposal, which is to say, what I'm imagining is in this Afrofuturist setting, this landscape is actually taken from an area called Domboshawa, which is near Harare, which is one of the places I grew up with in Zimbabwe. It's in the sort of semi-mystical future landscape, and there is this wall, which is a cellular automata, and then the character standing in front of it is a kind of diviner. In Southern Africa, you'd call the person a sangoma or a nanga, and they are reading the outputs of the cellular automata in order to make predictions. And they could be to do with the spread of contagion or weather or any other kind of upcoming data that they want to know about. So what I'm doing with this project is I'm challenging a couple of things. I mean, one of them is the invisibility of AI. So the reason I'm imagining this kind of fictional setup is to go, what would AI look like that was visible? So instead of just being black boxed and not knowing how it works, which is one of the critiques of AI or the problems of AI, this makes it visible so you can see it working. It is a conceit because Conway's game of life itself is not complex enough to make an AI, but other cellular automata are. But this is the gesture. It's also saying, what is the relationship between AI and divination? And that's some of the implications. And I have more questions than answers. It's just things that I'd like to pose to listeners. The binary system is based originally on the I Ching. I actually only found out about this recently, but Leibniz, the mathematician in the late 1600s, he came up with binary. And the way he came up with binary is he looked at the I Ching, and the I Ching is a system of divination where you throw 3 coins and then you get a set of lines, and lines can either be solid or broken. And it's a binary system. You either have a broken line or a solid line, and then you combine those broken and solid lines to create more complex patterns, and you make predictions based on them. The yin-yang sign is from the same place. The yin and the yang are the 1 or the 0. And so Leibniz in the late 1600s devises binary, and you can fast forward all the way today and see binary running behind all of our computation and ultimately AI. So another conceit there in my project proposal is to say, how far can we say that AI currently is a form of divination? You know, it's presented as rational, scientific, and technical, but is it also a continuation of much longer standing cultural practices around divining signs in order to make predictions about the future? And the urge to know the future is one of the driving forces. And if you Google AI and divination, you'll come up with quite a few articles, one of them in the journal Science from 2018, which is a critique from within the AI and machine learning community, identifying AI as a form of alchemy is what they call it. They're critiquing the way that data sets are interpreted in such a kind of a loose way, or a way that's very directed towards what kind of results they want, that it may as well be a form of alchemy rather than a form of science. So this project proposal, Village Oracle, is to create this shared virtual reality environment in which there is an oracle reading the output of a cellular automata-based artificial intelligence. You could, when the work is actually there, or the beginnings of the work are there, as in there is a VRC world already that contains some of those elements. When the work's completed, audiences and participants can come to that space and they can see the work up close, and they could be cast as characters in it or see an unfolding narrative. And the purpose of it would be to entertain and to provoke questions around AI and to imagine possible futures for AI. Thanks very much. That's it.
Thank you so much. That was all really fascinating. And we've had like 4 amazing papers. And I'm very happy to say that the floor is open for some questions and discussions, I think for about, would we have, let's say, 15 minutes at least, maybe more?
Well, we have 10 minutes according to schedule, but let's see how the questions get on, and we can stretch things a bit if we are so inclined. Thank you very much. I'll be fielding questions both here from the floor and as they come in online. Yes, we have a question in our live audience.
Hi, thank you so much. I really enjoyed all 4 of those presentations. I thought they were amazing. My question is for Ralph and Sophie, I think, and it's not particularly well formulated. but I'll just try and say what I'm thinking, and you can try and respond. Something that came up for me when I was listening to both of your presentations was this kind of relationship between visibility of AI, the way that people relate to the AI, and then the way that they understand what they're relating to. So I'm kind of seeing those three things: visibility, then relatedness, then comprehension. And I was struck in both of your presentations, Sofie, you drawing on Star Trek, and Ralph, the way that your art is created for a large audience, how people who don't necessarily have pre-existing technical knowledge of AI systems or how they work still see, relate, and comprehend these technologies, right? And I guess my question is just if you could reflect on that a little bit and how you've observed people relating to your work or to the things that you study and how you think that, yeah, that's it. Thank you.
Yeah, which of us go first?
Shall we start with Ralph? Yeah.
Okay. Sure. So thanks very much. I didn't catch your name.
Yeah, I should have said sorry. I'm Isabel Higgins. I'm a PhD student in sociology here in Cambridge.
Sure. Hi as well. Yeah, good observations and questions. I mean, I think that one example for me is that the wire art projects that I do, those little robots that I showed you at the beginning, you can see inside them. That's something that's straightforward about them, is that they're made with this wireframe approach, which means you can see the inner workings. And people have commented that they find that empowering because they can see what the mechanism is doing. And there is something in that for me that you could then apply to the approach to AI as well, which is to say, it's empowering when you can see how something works, and it can be disempowering when it's black boxed, and that there's an aesthetic component to that I don't know if you remember like Swatch watches that had like transparent case and you can see the clockwork inside them, but it's a certain kind of aesthetic where you can see the workings. And then there's another aesthetic which is to do with a kind of MacBook kind of sealedness. And I think I like to play on that idea of things where you can see inside. And then the pop cultural aspect, yeah, my work very much relates to pop culture, and it's about reaching out to people with spectacular, entertaining material that is relatable, but also has other material that you carry with it, you know, so you can insert your own messages into this pop cultural material. Thanks.
Yeah, I guess, should I build on that, or next question? What's the...
Yes, please, Sofie.
Oh, okay, great. So, yeah, I think with respect to sort of visibility and sort of relationships between sort of programs and AI and people and not knowing how things work or not being able to see, I think that definitely affects how machines are sort of constructed and perceived. An earlier draft of my work, for example, went in a weird sort of post-humanist direction where I actually did argue that the typewriters and Photoshop used in the Spinoza piece, for example, were collaborators and should be considered as such. So, and the people I presented to were really resistant to that idea. And so I just think it's interesting based on how when something comes across as other too, it's like, it seems to be more difficult to, you know, see it as like a potential collaborator and having autonomy, or even if it's unlike what we have. So just a reflection on, I guess, my work and what I've seen in responses.
Thank you. I have a follow-up question to that, Sofie, because we had yesterday, the day before, an excellent panel here on ghost fictions, where a team of presenters, some of whom are watching the live stream right now, presented work on AI-generated text and the role that they versus the AI played in there. And it does indeed sound from your presentation that you would say the role of the artist is diminished as opposed to the larger role that technology plays in it. So how do you see this as opposed to the idea of the artist simply choosing their tools but still being the person in charge, especially looking in the context of the artwork that we have just been looking at?
Yeah, so that's a good question. So how do I conceptualize like the role of the artist versus the role of the program or AI?
Yes, indeed.
Yeah, I would probably make a move wherein I wouldn't necessarily even frame it as the role of the artist being diminished. They're doing just as, like, it's more that there's different creativity being added. I might even look at the creative work. I haven't thought through this yet, but it's based on some other work I've done with expertise. We might even see creativity as being like emergent from the network of, you know, the artist curating the data set. In the case of the Tulips, right? So the artist curating the data set, Bitcoin going up and down in value, the language prediction model or visual GPT-2 changing the Tulips. So there are all these sort of dynamic actors playing roles. And I think there might be like legal ramifications to sharing something such as authorship in like a published product, but I don't think for the purposes of like philosophy and ethics, like thinking of these players as kind of like actors in a collaborative network, and the creativity or the art being what emerges from the network and is not something that resides in individual. If that makes any sense, or if that contributes, that might be a way of looking at it. And that gets into sort of notions of like relational autonomy and relational ethics. So it's not immanent, it's relational. Yeah.
Thank you, Sophie. Any other reflections from the rest of the panel? Not Tersus.
I would like to still point out that also, like, I think a lot of artworks that I've been looking at also bring forth this human labor that goes like trying to debunk the myth of AI being something outside the human, something non-human, and bringing the work visible. Also, one part of Anna's Anna's work is the mosaic virus, which is the actual data set that she usually exhibits together with the artwork. And this one she has labeled for hand and gone through all she has photographed the tulips and everything. And this also brings the amount of labor that is required in building data sets, here images, but also other type of data sets. So that was just like kind of this, at the same time as it can create new things that you are often, artists say that they're excited to see what comes out from the model. At the same time, the artist is also making a lot of choices and decisions that needs to be made visible to debunk some myths of AI.
Thank you, Linda. We have another question from the audience, from Jill.
Hi, I'm Jill Walker-Retberg, University of Bergen. My question, just thank you for very interesting presentations. I have a question that's sort of for Jill and for Linda, and it's about these questions of sort of ambiguity and classification, because we've had a few talks about how one Linda referenced, Miriam Elam, who talked about yesterday how AI often ends up classifying people and erasing those differences. But then we also had an artwork shown yesterday by Jake Elwaz, who used deepfake precisely to queer data sets, as he says, so you get all these in-between categories. So my question to Gilles is, do you think, are there any potential problems in locking down, oh, that's not quite what I want to say. What I want to say is some people, I think someone here discussed how trying to make data sets that cover the whole world can end up kind of globalizing things and losing some of the specificity of local communities and cultures. Would you want to expand your models into something global, or would that be problematic? What would happen? What happens when you use what you showed with the annotations of the African styles on other people's clothes, for instance? And then to Linda, it's a related sort of topic, but it's all your examples that you showed are about this kind of misgendering, putting in the wrong category, how it's flawed. Are there also examples of classification, or maybe in other modes of technology, artworks that sort of do that querying of the data set, or is Jake Elwaz really unusual in that? So maybe Jill first.
Okay, thank you very much for your question. Yeah, one thing that we have been really discussing about is whether we have to standardize the African annotations to the Western type annotations or not. And this leads sometimes to a loss of specificity. Yeah, this work is really a first attempt. And our goal was to build on top of what was existing. But I think at the end of the day, what we want to do is really to have some specific description of African images. And this is really, really important. And so we can have, and I can also imagine some models in which we can have both Western style and African style, but still make the model specific to some diversity and things. So they are not in opposition. I think we really, but there is a work that have to be done, and yeah, we have to care about this.
Thank you, Gilles. And Linda?
Yeah, of course there are artworks. I was especially choosing now artworks to kind of make my point in these presentations with a very short time. But there are artworks talking about this dirty data. What comes to my mind with this question first is a work called Interhuman by Isabella Salas and Nora Golick, and they have they kind of collaborated together using Nora's portraits that she's been using, and then they make these animations of people and their portraits, which are also like these walks in the latent space where it kind of morphs from different looking people to another, and this also like kind of talks about this diversity and these betweens, what is in between us as persons visually. So for sure, but like when we look at the models that are like basically what a lot of these artworks that I was talking about critique, like how machine learning looks like now, and certain categories within that specifically for humans are very, very problematic.
Thank you, Linda. Any further observations from our other panelists? Because if not, we have come towards the end of our time for this panel. So please join me in thanking our chair, Maya, and our 4 panelists for a wonderful panel. Thank you very much.
Thank you.
Thanks, everyone.
And with the end of this panel, we have come to the end of our conference. And the past 4 days have been a wonderful or journey, or should I say roller coaster ride through the massive range of possible ways of interrogating AI and borders, from examining both how AI operates at material borders, from national to physical, personal, bodily borders, to how AI produces or transgresses all these borders, including imagined, theoretical, and ideological ones, and of course the ways all of these categories are fundamentally interconnected. I've already noticed how so many presenters and participants have discovered new connections between their work, and I hope that the conversation started here will lead to much exciting work in the future. Now, this morning, Eleanor has already so splendidly thanked our team, to which I should add my thanks to her and to the other MCs of the week, Kerry Macarith and Stephen Cave. And further, I should thank the institutions that made the Critical Borders Conference possible, the Leverhulme Centre for the Future of Intelligence and the University of Cambridge Centre for Gender Studies, as well as Jesus College. And of course, our funders, the Obertsee Tenor Lectures on Artificial Intelligence and Human Values, the Leverhulme Trust and Christina Gore. And a special thanks, of course, to Professor Ruha Benjamin, who is currently on her way back to Heathrow, for delivering such a wonderful and inspiring Tanner lecture to start off this conference. In case you have missed any of the conference, the video recordings are already available. Each day of the conference has its own link on which you can access its recording through the Future Intelligence account on YouTube, including the link to the current live stream, which will turn into a permanent recording at the end of my closing words. The video of the Tanner lecture is currently being edited and will be released by Claire Hall soon. And this just leaves me to thank the audience, both here in person, in some ways defying all odds and travel restrictions and post-Brexit bureaucratic nightmares, to be here with us in person this week, as well as our virtual audience, the several hundreds of people who tuned in over the week to join us to ask questions and to join the conversation on Twitter. Thank you all very much, and I hope to see you again soon, whether in person or virtually. Thank you.